All right, guys, our timer is a little off down there in the bottom right-hand corner, but it is 10 o'clock, so we are going to get started. Good morning, and thank you for joining us and taking some time out of your busy schedule to join this week's installment of the Long Coffee Break. My name is Chris Visconti, and I'm a sales engineer on the hydronic and plumbing team here at Long. And this morning, I'm very excited to be joined by Rob Curtis with Tower Tech. And Rob is going to do his best to help us answer the age-old question of, can your cooling tower do this? Take it away, Rob.
All right. Well, thank you. It's exciting to be a part of this coffee break presentation, and looks like it's a really cool thing that Long is doing, and glad that they've offered us the opportunity to present. And I do want to go ahead and get right into it. So thanks everyone for joining. My name is Rob Curtis. I'm a regional sales manager with Tower Tech based out of Oklahoma City. The question comes up, can your cooling tower do this? And say, why would we even put that up there? We were asked that question. People would say, why can't your cooling tower do this? Can you solve this? Can you do that? And so we begin looking at what can we do to be able to answer those questions. So that's what we're going to talk about today. And we have some items that we're going to kind of cover here to try to make sure and cover the areas as it relates to cooling towers. So when you look at cooling towers as it relates to energy, maintenance, safety, the environment, the longevity of those products, these are important areas that people had a lot of questions about of what our cooling tower could do. And so we're going to talk about those. I think to be able to kind of give you a little kind of brief review of it, I want to kind of go through the cooling tower real quick and address some of the components that we do want to be able to talk about. And so the first thing I'm going to kind of go through here is kind of how the water flows through the tower. So let's just take a look at that, and then we'll highlight some of the components and get right into some of the features of those components. So water's entering the cooling tower through this header lateral system, and as it enters in, it hits this nozzle, and this is a what we call our spin-free distribution nozzle. That's some patented technology, and there's a lot of maintenance and energy and safety benefits of that product that we're going to cover as we go through this presentation. And then water flows through heat transfer material right here, as you can see. It's kind of dark, but that's just standard heat transfer media, fill material in the industry. And then it hits another component that Tower Tech addressed, and that is our patented water collection system. And what we're doing here is we're collecting the water, allowing air to pass through, and then discharging that water to the perimeter of the cooling tower. This component, this development, has a whole lot of features that we're going to be talking about as we go through. And it really impacts as the water flows through this tower and goes out to the sump box here. You notice this other item, enclosed flow through basin. That's what Tower Tech has developed. And there's a lot of features of this basin that we're going to be talking about and how it impacts chemical treatment costs and maintenance on a tower. So that's one that we want to focus on too. And then you look at this at the bottom here, we've got the bottom mounted direct drive fan motor system. And that's something really kind of unique, not used to seeing fans on the bottom of the tower. And we're going to talk about that one too, and how it has impacted maintenance and energy and safety and even the environment. And then the last item here is the pultruded FRP basin. We're going to be talking about that. Tower Tech completely corrosion-free design, and we're going to be getting into the longevity of a product and answering that question that people had of how to make towers last a little bit longer. So we're going to get right into the first item here, which is our distribution system. And the first thing that you see when I pop up this next slide is you see some pictures of a traditional cooling tower nozzle system on the top left. That's a traditional nozzle. To the right would be a traditional basin. And those nozzles have very small orifices in them, which tend to scale up, and you have fouling of the distribution system. And then you have to go up on top and clean those nozzles out, as shown here. What Tower Tech decided to do when someone said, can you figure out a way to be able to make this distribution system less of a problem? Well, we designed our spin-free distribution nozzle. This nozzle being a 1/2 inch up here, this nozzle being 2 inch, you have a 400% increase in orifice size, which also allows the media to not back up and plug inside of it, anything that tries to get in it. And then we have the spinning disc. That disc dislodges anything that tries to build up into it. And so that solved the cleaning problem and reduced maintenance gives us even better energy efficient, makes a lot safer product. Okay. And then when you move over here to the next picture here, this is an actual picture of our distribution system where you can notice it's in a corner. So it's square. You had a square pattern design that TowerTech developed with this nozzle. We distribute the water in a square pattern. Now, traditional nozzles, as you see here with this pattern, would be round circular patterns that have void areas in them. They have less efficiency. They have the potential to have more maintenance issues with them. So TowerTech solved that with the square pattern. And then when you look at the variable flow item here, notice to the right, this would be a similar pattern in the event that you reduce flow across a cooling tower. That's what typically would happen. More void areas, more chance for wet, dry locations, and less efficiency. However, TowerTech's design with that tapered shaft and the spinning disc allows us to keep that water spread across 100% of the surface area, even when we're reducing flow. And that will impact energy significantly and also keep the tower in optimum shape even when you're reducing flow from a maintenance perspective. So we're going to jump to the next item, and this is the water collection system that we showed. It's really core to some of the other features, so I wanted to just highlight it real quick. And that is, when you look at this distribution, the water collection system and how the water is distributed through it, water is flowing from the fill material into this water collection system. And what we have is this vein overlapping the bottom vein. There's just a network of veins in here. And when we overlap this, then the water has no place to go but between that point, those 2 points of the overlap, and it has to fall into that channel. However, air has the ability to be pushed up through the cooling tower in the open space underneath, and we turn the air and push it up through the cooling tower. So this development allows us to separate the water from the air and allow us to discharge that water to the perimeter of the cooling tower and the air move on up vertically through the tower. So that technology has allowed us to develop the next thing, which is our enclosed flow through basin design. And so when you look at these pictures, these are traditionally what we would see with towers need to be maintained, basins needing to be cleaned, either through shop vacuuming it out, using a high suction hose to try to get that debris off the bottom of those basins. Or you can drain the basin and you come in and shovel it out. And then sunlight's been a problem because you have algae growth and biocide demand increases when you have more sunlight hitting that tower. So we were asked the question, what can you do? How can you get a cooling tower to minimize some of these things? And that's where when we developed the water collection system, and now we take that water and put all that water to the perimeter of the cooling tower, what's happening is we're putting it in a much smaller area, like going through a piece of pipe. So now you're moving the water at a higher velocity. Now we can now we keep the solids suspended so that they can go out to the cleanup system and let it clean up, filter it out, or go out the blowdown as opposed to settling in the tower. That has allowed you to reduce your maintenance on cleaning basins out, because it's a self-cleaning basin. In addition, because of us keeping those solids suspended, we're able to have less water being discharged to the drain, which means that you reduce your water cost and you reduce your chemical treatment cost. And then because the basin's elevated and we're moving that water so fast, you do not need basin sweeping systems. So you don't have to have the cost of operation year round of a basin sweeping system. And then that reduced light, the eliminating the sunlight, out of the tower now reduces the biocide demand. So you have less chemicals required in that. So that enclosed flow through basin design really is a true shift in the way that things had been done and solved a lot of problems that we had been given or challenges we were given to solve some issues. Okay, we're going to move now to that bottom-mounted multiple direct drive fan system that TowerTech has due to the water collection system. Traditionally, again, you have single motor designs with belt-driven units or gear-driven units up on the top of the cooling tower. And oftentimes when they fail, it's very difficult. It's maintenance intensive. You have some safety concerns about getting that equipment off the top of the cooling tower. When you look at what TowerTech has done, is now the cooling tower sitting on the ground, the fan and motors are reachable from grade level. So you can walk underneath the cooling tower to access it. So bottom mounted equipment, reduce maintenance, reduce safety issues. So you don't have to worry about as much safety and longevity of the product because it's in the intake dry air stream and not the hot, moist exit air stream. And then we went direct drive, said eliminate. How do you eliminate maintenance? Eliminate the components that cause it. So we eliminated gearboxes and belts and drive shafts and shim packs and go with just a motor directly connected to a fan. That has a direct impact on the maintenance of the product and also the safety of it. And then the last item on this mechanical equipment, if you notice here to the right, we have a picture of a TowerTech tower, and you can see the 6 squares underneath there. So that represents, each square represents a motor and a fan. So TowerTech, instead of having a single motor, single fan, we have a multiple direct drive system. So if you happen to lose one, you have redundancy. In this case, we have 5, 6 running. If you lost one of these, you lost 100%. And so that gives you some reliability and redundancy, and also some flexibility in how you're going to operate your system. So when you look at our bottom mounted multiple direct drive system, we really impact some of the concerns and questions people would ask about, can your cooling tower do such and such? And then moving to our next item, which is the pultruded FRP basin, casing, and structure of the tower. We were asked the question, hey, can you design something? Can your cooling tower last longer? We really would prefer it to be more than 5 to 10 or 15 years. And so we looked at the different materials of construction and know that metals will corrode and rust, and it's decided to go with a completely inert material, which is pultruded FRP. It's completely corrosion free. We designed it for 200-mile-an-hour wind loading, worst case seismic in the United States. And we're using a process called pultrusion, which allows us to put veils on both sides, 2 smooth surfaces, and to give you also UV inhibitors on the surface of that to give long life to the product. So that's another area to increase longevity that we answered the question that was asked of us. I would be remiss, I feel like, if I don't at least mention this item because it is important. And we're winding down here in our presentation, but drift into a cooling tower used to not be a problem. But over the years, people have become more concerned about it due to Legionella, due to more equipment having failures because of water getting on that equipment. And one of the areas that people look at is, what is the drift rate of your tower? And traditionally, typically today, you see drift rates of 0.005% of the recirculating rate of water. Well, TowerTech has went in and designed our tower so that it is 0.004%. That's 92% less. And that's due to the fact that we have a force draft design with a very high efficient drift eliminator, but also because of our water distribution system droplet size. And that is part of our patented technology that allows us to attain the lowest in the industry when it comes to drift. So thinking about this, on a 1,000-ton tower, you'd have 216 gallons of water leaving that cooling tower, exposing equipment or people to bacteria, Legionella, where with TowerTech, you reduce it down by 92%. So drift is something we addressed when people asked about, can we attain lower drift? And then installation-wise, as far as how can we get the tower installed quickly, efficiently, and with the least amount of safety issues? Well, how about having it completely assembled? One pick, set it in 30 minutes. Everything can be ready, start piping and wiring it as soon as it's set. So that is tremendous when it comes to reducing the amount of time on site, crane time, installation time, safety of putting towers together, and not compromising quality because everything's manufactured out of the factory. So we believe that has addressed some more questions about what we can do. And then what about the warranty of the product? Typically, you see warranties of 1 year to 5 years. TowerTech's warranty is 15 years, parts and labor, material and labor on our basin, on our casing, on our structure, and then 5 years on everything else. So we really address that question too, of trying to improve that with the quality that we put into the product. We can offer that type of warranty. And then to kind of tell you a little bit about the models that we have. We actually have 2 different sizes of modules. One is we call our side-by-side, and then we multiply that in lengths. So we have a unit that starts with 400 tons, goes all the way to 1,200. I didn't show the 1,200 here, but it's we stop at 1,000 there, but we do have a 1,200-ton unit. Then we can also have what we call our I-line series towers, a little narrower, and they go from 100 ton to 600 tons. So really we can cover any single tower module installation up to 1,200 tons. And then we can multiply that to meet any heat load requirement. We have installations as small as 100 tons, and we have installations as large as 60,000 tons installed. So we can meet pretty much any requirement that your building or facility might need. Whoops. And then just to kind of finish up here, we're just showing you a few pictures of the installation of how it would look. This is a 10,000 ton plant for a data center that we put in, and you can see we're using TowerTech legs here and equipment put underneath it. Or you can see this one here where you would have it mounted on existing steel or new steel, whichever one you would prefer. So we can do either one just to kind of show you how they're installed. So one of the things about TowerTech, and I'm finishing up right now, this is the end of my presentation, but I wanted to leave us with this, and that is one of the things that TowerTech is that's really important to us is one of our core values is we call sustainable efficiency. And that is we set out to be able to not only provide a sustainable piece of equipment, but also a energy efficient piece of equipment. And oftentimes that's difficult to do because of the cost involved with trying to accommodate that. And we feel like we bridged that gap. We found sustainable efficiency, we found energy efficiency, and so now we can save the valuable resources and still provide a very competitive product to our customers. So with that, I'm going to go ahead and finish up and turn it right as I have to close it out.
All right, thank you, Rob. That was some great information, and it was a lot of information in a short period of time. So please, if you have any questions or you're interested in getting into TowerTech a little bit further, please reach out to your Long sales engineer. And don't forget to join us next week when Jeff McBride will be presenting the Long Coffee Break with Daikin, and they will be addressing AHRI 260 VRV sound data. Thank you very much, everyone, for joining us, and have a great rest of your day.